They built it to rot, and that's why it survived for centuries. A hand-shaped timber beam cut before gunpowder warfare is still carrying weight today. Not behind glass, not sealed in plastic. It's doing real work. Meanwhile, modern sealants crack, peel, and quietly fail in 20 years or less. That contrast should bother you, because it exposes a truth most modern building culture avoids. Medieval wood preservation wasn't primitive, it was brutally effective, and in many ways it still outperforms what we trust today. This isn't nostalgia, this is performance. Medieval builders didn't lose this knowledge because it stopped working. They abandoned it because industrial timelines didn't have patience for systems designed to last centuries. Once you understand how medieval carpenters thought, modern failures start to look obvious. Let's get straight into the mechanics. They never tried to make wood waterproof. This is the mistake modern construction keeps repeating. Rot does not begin with rain. Rot begins when fungi get three things at once: food, oxygen, and stable moisture trapped inside timber. Modern sealants chase waterproofing. Medieval builders chased something smarter. They let wood get wet, and then they made sure it could dry. Modern coatings form a hard skin. Wood moves, the skin cracks, water gets in, air gets in, moisture stays trapped. Decay begins where you can't see it. By the time damage shows, the structure is already compromised. Medieval systems worked because they cooperated with wood instead of trying to dominate it. They slowed decay rather than pretending it could be sealed away forever. Pine tar worked because it went where modern sealants never do. Across much of Europe, pine tar was trusted the way modern builders trust pressure-treated lumber. It wasn't an experiment, it was infrastructure. Pine tar was produced by slowly heating resin-rich pine in low oxygen pits, yielding a thick, dark substance loaded with natural antifungal and water-shedding compounds. Here's the critical difference. Pine tar doesn't sit on the surface. It penetrates deep into the grain. It keeps wood flexible. It sheds water instead of trapping it. It slows fungal growth without sealing pores shut. And most importantly, it allows moisture to escape after rain. That's why, medieval roof shingles, ships, doors, tools, and structural beams survived cold, wet climates for centuries. Pine tar doesn't harden into a brittle shell. Instead, it ages with the wood. Modern applications still follow the same logic, really. The timber must be fully dry. Pine tar is gently warmed until it flows. Thin coats are brushed on, not sprayed. Multiple applications over several days allow deep absorption. Mixing pine tar with boiled linseed oil, a blend used in later medieval and early modern Europe, improves penetration and curing. This still works today on sheds, barns, fences, tool handles and restoration projects where, honestly, longevity matters more than showroom shine. Medieval preservation started before the first joint was cut. This is where, modern builders fall behind. Medieval preservation was not an afterthought. It was part of the build itself. Timber selection mattered, seasoning mattered, orientation mattered. Treatments were applied before wood was locked into places where moisture could hide. Modern construction waits until the end. Slap on a sealant. Call it protected. Medieval carpenters assumed maintenance was inevitable and designed systems that could be renewed without stripping layers or trapping water. That mindset alone explains why so many medieval structures outlast modern ones. They were designed for repair, not replacement. Lime wash turned biology against rot. Where pine tar wasn't suitable, especially indoors or on visible framing, medieval builders turned to mineral solutions. Lime wash was one of the most important. Made from burned limestone, lime created an alkaline surface hostile to fungi and insects. But it didn't stop there. Lime reflected light. It reduced surface moisture. It allowed air to move through timber. Beams in halls, barns and cellars were, repeatedly brushed with lime wash, especially in smoky or humid environments. This wasn't decoration, it was biological control. Ash-based washes worked the same way. Wood ash mixed with water and strained produces a solution that raises surface pH. That shift alone makes wood less welcoming to decay organisms. Modern builders can still apply this logic. Lime wash works exceptionally well on interior structural wood and shaded exterior areas. Ash water can be brushed onto unfinished wood before assembly. These methods don't seal wood off. They change the conditions rot depends on. Iron fasteners weren't a flaw, they were part of the system. Here's a detail most people miss. Medieval carpenters often paired oak and other tannin-rich woods with iron fasteners. When iron oxidizes in contact with tannins, it forms iron tannate. That compound resists decay organisms. It darkens the wood, which is why beams around medieval nails often appear blackened. That darkening isn't damage, it's strength. This explains why wood around old iron fasteners is often harder and better preserved than the surrounding timber. The metal wasn't a weakness, it was chemistry. A modern equivalent is straightforward. Untreated iron hardware paired with oak or chestnut recreates the same reaction. Even iron solutions made by soaking iron scraps in vinegar can be brushed onto tannin-rich wood to trigger the effect. No synthetics required. Design did most of the preservation work. Medieval builders never relied on treatments alone. Design carried the load. Beams were raised off soil on stone bases. Roofs were steep to shed rain quickly. Eaves extended far beyond walls. End grain was protected through joinery instead of being left exposed. Airflow was always considered. These choices prevented stable damp conditions from forming. Fungi need consistent moisture. Medieval buildings were designed to deny it. Anyone building today can apply the same logic. Keep wood out of direct soil contact. Allow ventilation beneath floors. Design structures that dry rapidly after rain. No sealant can compensate for bad design. Medieval builders understood that instinctively. Modern sealants prioritize speed, appearance, and short-term guarantees. They harden, they crack, they fail invisibly. When they fail, they trap moisture where it causes the most damage. Medieval methods prioritized long-term performance and repairability. Pine tar and lime wash could be renewed without stripping layers. Maintenance was expected and, well, really quite simple. These systems weren't abandoned because they failed. They were abandoned because, honestly, they didn't fit industrial timelines. World War II accelerated that shift. Industrial building demanded speed, uniformity, and materials that, required minimal skill to apply. Longevity beyond a few decades stopped being the priority. For restorers, homesteaders, and anyone thinking beyond fragile supply chains, medieval wood preservation offers proven low-tech solutions. No factories, no petrochemicals, no planned obsolescence. These methods have already survived centuries of weather, neglect, war, and use. Fires, freezing winters, social collapse. Few modern systems can claim that record. If you're building or restoring anything meant to last, well, start by rethinking your goal. Don't try to make wood waterproof. Instead, make it, hostile to rot. Season your timber properly. Apply treatments before assembly. Use pine tar and linseed oil blends on exterior wood that needs flexibility. Use lime wash on interior structural beams or shaded areas where moisture lingers. Raise wood off the ground. Design for airflow. Protect end grain through joinery, not plastic caps. If you work with oak or other tannin-rich woods, consider untreated iron fasteners or iron-based washes to trigger natural decay resistance. Expect maintenance. Build systems that can be renewed instead of sealed shut. This is not reenactment. This is applied historical engineering. The past didn't survive by accident. It survived because people built with time in mind. If this breakdown sharpened how you think about craftsmanship that lasts longer than a lifetime, subscribe to Old World Prep. Share this with anyone who builds, restores, or cares about skills that don't expire when the warranty does. The past still has work to do. Old World Prep.